Hello everyone, my name is Keyang. Today I'm going to present my final project, the Federated Smart Home User Behavior Modeling System. So at the beginning, we can see some of the trend. So basically from this graph, we can see that the connected IoT devices has a 5 times increase for through the over 10 years. And still the IoT devices are vulnerable to various kind of attack, including network traffic decryption or traffic volume or traffic rate analysis, and it will present many kind of privacy leakage, including the smart home occupancy and also the user activities within the smart home. So here we have a attacking scenario listed here. So the unpassed adversaries can capture your network traffic information through your route to the ISP and to the internet. And the unpassed adversaries may have different kind of monitoring approaches, including like monitoring your network traffic traces or just monitor the network traffic volume data. And here we have some different kind of prior research regarding to the user activity attacking, and it includes the device fingerprinting or traffic demultiplexing. Also, they can also rely on the protocol flaws to just capture the information within the packet. And also they have different kind of evaluation matrix, including the adversary confidence, which can be applied to the adaptive adversary. And also in the machine learning level, they also have the accuracy and the F1 score. And also they have the root relative squared error. However, for different kind of matrix, they have different kind of applications, and there are no standard way for different kind of evaluating matrix. So and also this kind of private work has present different kind of limitation, including lacking a widely accepted and easy to access attacking models, or lacking a reliable evaluation matrix, or lacking a publicly available IoT traffic datasets. So here brings our research problem. We would like to present a deep learning based adversarial attack model framework, and it can enable a set of general sophisticated adversarial attack models that can be leveraged by the researchers and other users from the IoT security community to better evaluate the work. So basically, our design are in 3 different parts. The first is the data collection and the pre-processing. We first collect the IoT traffic network traffic data from the router, including from the router installed with DDWRT and TCP dump. And then we're going to do a user tunable adversarial machine learning and modeling. And then is the performance evaluation part. So we will introduce these 3 different parts. So our data collection are basically running on a Netgear router, and it was flashed with DDWRT router system, which is a Linux-based smart router system. And we use TCP dump to capture the network traffic data. And then in order to do the analysis, we're going to clean the PCAP file into a CSV format with the traffic volume data only. And we're going to do the resampling to use it into like 1 second granularity or 1 minute or 10 minutes. And for the user tunable adversarial machine learning modeling, we have 2 different parts of the optimization for the machine learning model. Basically, we have the kernel selection and grid search for different kind of machine learning models. And also we're going to do the cross validation. We have a preset n-cross folds and m random states to avoid a model overfitting. And also we are going to do the train and testing data splitting. And we have a dual mode evaluation, including both pre-trained and retrained model. And for the performance evaluation matrix, currently we're using the MCC and Cohen's kappa as our evaluation matrix. The reason is because that we don't want to this kind of data's unbalancing have effect on our performance, on our evaluation fairness. So as we can see from the graph here, the red bar is the F1. As we can see, for a highly unbalanced data, the F1 can still get a high result even if the model is not perfect. It is not perfect since their MCC and Cohen's kappa are relatively low. Our implementation is here. So basically, we have a DDWRT router to capture the network traffic data from the IoT devices, and our system can be run on a Raspberry Pi and equipped with a touch screen. And we have different kind of IoT devices like smart voice assistants, smart hubs, and also plugs and controllers, different kind of things. And our experiment result is showing here. We have 12 totally 12 different user activities listed, and we are just showing 4 of them. And we have used 11 different kind of machine learning algorithms, and as we can see from the graph here, so all 4 user activity shows here have for almost all the machine learning algorithms, we can get a relatively good result. And for the graph on the bottom left, the take care of the baby. So even many other machine learning algorithms are not so good, we still have at least one machine learning algorithms performing has a really high MCC value. And here is the table shows that all the machine learning algorithms and their MCCs applying to different kind of user activities. As we can see that we can always find a good performing machine learning algorithm on attacking the user activities. Alright, so the following part will be the demonstration for the code, and thank you. Hello everyone, my name is Keyang. This video is the demo for the final project of class telecommunication software and methodologies. So my project, its name is the Federated Smart Home User Behavior Modeling System. So basically in this project, we're going to employ multiple kind of machine learning and deep learning algorithms to do the data mining of the user behavior information lies under the network traffic generated by IoT devices in the smart homes. So we're going to show how the code runs and how the result looks like. So let's begin to introduce the code first. So the first code fragment is the PCAP to CSV, which means that in this code we're going to convert the PCAP file we captured from the router on the TCP dump. We convert the file from PCAP to CSV files for future processing. And then we're going to do the CSV cleaning. So basically we're going to label the CSV as we need it. We're going to label different columns, and also we'll do the first step of the cleaning. So for example, we don't want to remove all of the local traffic, since this has no contribution to our internet traffic analysis. And also we're going to remove other protocols except for TCP and UDP. So the first and second steps are both really slow, so we're going to use the multi-process to speed it up. And once we got the label device information, we're going to label the device based on the MAC address within the within the network traffic. So in this case, we can see what kind of device the users are interacting with. So after finished the labeling, we're going to move on to the human activity classification. So here we can see we have different kind of machine learning algorithms, including like naive Bayes, k-nearest neighbors, decision tree, and we also have a support vector machine in different kernels. And also we have already tuned the parameters so it can perform better than the default setting. And in the human activity classification, we can get the result of the false positive, false negative, true positive, and true negative. And the last step, we're going to calculate the evaluation matrix, including the accuracy, precision, recall, and also we want to see the F1 and the MCC of our result. So okay, let's begin. So the code running really slow since it's n gigabits level data, so we're going to speed up the video for a better viewing. Okay, so the first step, we're going to do the conversion. As we can see here, we are creating different folders according to the date. So here currently there are 8 different processes, and we're going to finish it in crowding in like 15 minutes. Alright, so it cost almost half an hour, and currently we have all of the converted CSV files. So for each day we have 4 different CSV files, and similarly we have the like the pcap files. So these 4 different pcap files are coming from 4 different Ethernet interface from the router. So basically Ethernet 0, 1, and 2 are all from the unencrypted data, and the VLAN 2 are the VPN encrypted data. So the next step, we're going to do the CSV cleaning, and similarly we're going to use the multitask to speed it up. So after this step, we will have a clean CSV file with only 8 different columns and only the TCP and the UDP protocols as we needed. So the output will be sending to the result folder. Okay, so the error is because we are missing one device.csv. So let's put it back to the to the CSV test folder, and it should be good right now. Yes, so we're going to use the device list CSV to label the data, and then we're going to do the detailed labeling. Alright, so we almost finished the CSV cleaning, and as we can see from here, we have the column of time in second granularity, and the length indicates the traffic size in each second, and also we have different devices listed here in different columns. So we're going to use this kind of pre-cleaned CSV files to do the device labeling and also the human activity classification. Alright, so here we have already combined all of the 106 days data into 20 files, and also still in the seconds granularity, and we are just labeling the device by incoming traffic and outgoing traffic, as well as the traffic size. So we're going to use this kind of data for the human activity classification. So basically this is an unsupervised labeling, So with this pre-labeled data, we can first do the supervised training, and then we can use this kind of trained model to do the further unsupervised training and testing on the human activity classification. And the evaluation of the human activity classification will be showed here. And once we got the true positive, true negative, false positive, and false negative, we can use it to calculate the evaluation matrix we used. So here we can see for each activity, so we're listing 12 activities in total here. We can see the true positive, true negative, false positive, and oh no, this is false positive, false negative, true negative, and true positive. So we're going to use this kind of information to calculate our evaluation data. Okay, so here we can see our final result. So basically for 12 user activity as total, and the result graph has been plotted in the project report as here. So we can see that for 12 different users in home activity, like taking care of baby or walking at home or control lights, control plugs, we have all the machine learning algorithms have a average MCC like over than 0.5, and for all the activity we have at least one real accurate algorithms that can make the MCC higher than 0.8. Okay, so that's the demonstration for the final project, and thank you for watching.